Once again, welcome all to my channel. In this video, I have discussed regarding the BPUT MCA previous year semester question of object-oriented programming using Java for the year 2021 and 22. Here I have discussed the part 1. Okay, so the part 1 consists of 10 questions and each question carries 2 marks. Now the first question is question number 1, bit A. State the advantages of object-oriented programming paradigm. So it is a theoretical question. So the answer means here you can consider more number of advantages, but here I am focusing on 5 advantages. First one is the modularity approach. Okay. Second is the code reusability feature. Okay. Third one is the code flexibility feature. Fourth one is the problem solving in an efficient way. Fifth one is the security. So these are some advantages of that object oriented programming paradigm. Apart from that, some other advantages are also there. Okay, so next come to question number 1, bit B. So distinguish between data abstraction and data encapsulation with example. So data abstraction means it is the process of representing the essential features without including the implementation details or background details or unnecessary details, whereas data encapsulation is nothing but it is the process of wrapping or combining the data member and member functions into a single unit. Okay, now in case of data abstraction, the implementation hiding is done here. Okay, but in case of data encapsulation, the information hiding is done. Now it can be performed using interface and an abstract class. Data abstraction mechanism can be performed using the interface as well as abstract class mechanism, whereas the data encapsulation can be performed using different access modifiers. And normally data abstraction is focused on what part of the programming purpose. Okay, what it is focusing on the what part, whereas the data encapsulation process is focusing on the how. Okay, and it can for example, car can be viewed as a car rather than its individual components. Okay, so data abstraction means only you focus on what you want, not its background details. So car can be viewed as car rather than its individual components. Okay, we are not bothering about what are the components of the car. Then data encapsulation, one example is that a capsule which is mixed of several medicines. Okay, so now we will move to question number 1, bit C. Is Java a platform neural language? Justify your answer. Yes, the answer is yes. Java is a platform neural language. Why? Because the same Java code will run on multiple operating system or multiple platforms without any modification. And here it can also be focused on write once and run anywhere. That concept is focused here. Okay, that is about the question number 1, bit C. Now we will move to question number 1, bit D. State the rules for naming Java identifier. So generally the identifier refers to a name of a variable or function or array. Okay, so what is the rule for writing that identifier actually? So normally the identifier consists of letters, digits, underscore symbol and dollar symbol, but rule is what? The starting character or the first character should be a letter or underscore symbol or dollar symbol. Okay, so the first character must not be a digit. So identifier must not start with a digit. Identifier must not contain any white spaces. There should not be any spaces. Okay, when you are writing the identifier, keywords cannot be used as the identifiers. Okay, so these are the rules for naming the Java identifiers. Now question number 1, bit E. Now one program segment is given. We have to find out what is the value of x and y if m assumes the value of 0 and 1. Okay, suppose I am considering the n value is 0. So before that x is 1, y is 2. So when n is 0 means 0 is greater than 0. The condition is false. That means we cannot enter into the if block. Okay, so as there is no bracket is given, so generally when no bracket is given, so first line is assumed to be within that if block. Okay, so here not the second one can be assumed to be inside the if block. So the first one will be assumed to be inside the if block. So as the condition is false in this case, first case, so we cannot execute the x equal to x plus 1, so we have to skip that if block, and next statement is y equal to y minus 1. So that means before that y value is 2, so 2 minus 1 I am getting 1, so x value is 1, y value is 1 in this case. Now when the n value is 1, so in the second case what will be the output? So x is 1, y is 2. When 1 is greater than 0, yes, we have to enter into the if block. So x equal to x plus 1 means previously x value is 1, now x value is updated to 2, then y equal to y minus 1, that means y value is again decremented by 1, so that means x to y1. So the value of x and y are 2 and 1. Okay. Next question number 1, BPUT, state the difference between the instance variable and class variable. So generally instance variables are created when an object is created, okay, and the non-static variables are known as the instance variable, whereas the static variables are known as the class variables. Okay, so instance means these are the non-static variables, and class means these are the static variables. Okay, so variables at the class level are generally referred to as the class variables, whereas variables at the object level are called as the instance variables. Okay, so next is question number 1, bit G, write down the significance of super keyword with suitable example. Actually the super keyword can be used to refer the parent class object, or it can be used to call the parent class constructor from the child class, or it can be used to pass the value from child class to parent class. Okay, so these are the three different cases where we can use the super keyword. It is used to refer to the immediate parent class instant variable. It can also be used to invoke the immediate parent class method. Okay, it can also be used to invoke the immediate parent class constructor. That means it can access the, or it can deal with the variable of the parent class, method of the parent class, and constructor of the parent class. So some examples are given here. Suppose I am considering the first case, how we can immediately or how can we refer to the immediate parent class instance variable. So one example here given, class A is there, suppose string C equal to red, then class B extends A, suppose string C equal to green, then we have to display the value of C and super dot C. Okay, now in class D main function is available. I am creating the object of class B, K is the object, then K dot display means your display function will be called. Now system dot out dot println C, only C means it will focus on the local value. Okay, that means the C value of class B, so it will print green. When super dot C means it will access the C value of parent class. So super keyword is used to, in this case, is used to access the C value of parent class. Now it is red. So in this case the output is green, red. Now come to the second case. Then it is used to invoke the immediate parent class method. Now here similarly, here I am defining the DISP1 function in class A, and class B I am defining again DISP1 function. Then DISP2 function is available here. Then within DISP3 function I am calling the DISP1 function by the help of super keyword, then DISP2 function. Now here I am defining another class T where main function is available. Then I am creating the object of class B, then I am writing K dot DISP3, so this function will be called. Then within that I am writing super dot DISP, so it will not access the DISP1 function of class B, so it will access the DISP1 function of class A. Now it will print class A. Then as we are inside that means we are executing the DISP3 function, then DISP2 function is calling again, so it will print hello. So in this specific example the output is class A, hello. Now come to the third case. It is used to invoke the immediate parent class constructor. Okay, suppose class is there, A is the constructor which will print class A. Then within class B I am writing that class B constructor, then I am calling the super function, super with opening closing bracket. Okay, then I am printing the class B. Then class T is defined where main function is available. Then I am creating the object of class B. So as per the rule of constructor, when any object will be created, that constructor will be automatically called. So as I am creating the object of class B, so the B class constructor will be called. Now as I am writing super within opening closing bracket, so it will call the constructor of parent class, so it will print class A. After that as we are executing that B constructor, then it will print class B, so the output should be class A, class B. Okay, now question number 1, okay, now we have completed that G bit. Now question number 1, BPUT, what are the wrapper classes? Give an example. So wrapper classes are used to convert the primitive data type into corresponding object and object into primitive data type. So wrapper classes are generally used to convert one type to another type. Either it is from primitive type to that object type, okay, or object to primitive. Okay, so I am taking one example. Suppose boolean is the primitive type, its wrapper class type should be boolean with B capital. Similarly, for char, the wrapper class should be character. Likewise, for different primitive data type, we are getting the wrapper class type. Okay, so one example is taken. Suppose I want to convert primitive to wrapper. So how can we proceed? So class is there, main function is available. I am defining like that int equal to 30. So a will be initialized to 30. Then I am writing integer k equal to a. So this process is known as autoboxing, means the content of a will be assigned to k. Okay, so that's why it is one example of autoboxing, that means primitive to wrapper. Now here finally we want to print the value of a and k, so it will print 30 and 30. Okay, then I am taking, suppose this example is primitive wrapper. Suppose I am taking wrapper to primitive. Okay, that means integer equal to integer 10. Okay, it is given. Then if I am writing int k equal to a, means a value is assigned to k, which is a integer type or primitive type. That process is known as unboxing. So here it will print 10 and 10. Okay, so the process of converting primitive to wrapper type is known as autoboxing mechanism. The process of converting wrapper to primitive is known as the primitive to wrapper is the autoboxing, and wrapper to primitive is the unboxing process. So very simple examples are given here. Okay, next question is question number so come to question number on bit I. So what is the difference between overloading and overriding a method? Okay, overriding and overloading a method. So in case of method overloading, when more than one function same name are available in a class, but they have to vary either by number of argument or data type argument or ordering of argument. That process is known as method overloading. Whereas when more than one function the same signature or prototype are available in a program, that is known as method overriding. So it is the example of method overloading is the example of compile time polymorphism, whereas method overriding is the example of runtime polymorphism. So here in case of method overloading, it may or may not require the inheritance mechanism, whereas in method overriding it always requires the inheritance mechanism. Okay, so here methods must have the same name and different signature, whereas in case of method overriding, methods must have the same name and same signature. And in case of method overloading, return type can or cannot be the same, whereas in method overriding, return type must be the same. Okay, these are the some difference between method overloading and method overriding. Now we'll move to question number on bit J. What is unchecked and checked exception? So unchecked exception means these are the exceptions that are not checked at the compile time. Okay, so it occurs at the time of execution, that is the unchecked exception. Example, arithmetic exception. Whereas in case of checked exception, these are the exceptions that are checked at the compile time. Okay, so the exceptions which are checked at the compile time, generally checked exception. Those are not means are checked at the compile time, but they have checked at the time of execution or runtime, then that is known as the unchecked exception. Okay, and in case of checked exception, the example is class not found exception. Okay, this type of example comes under the checked exception, whereas arithmetic exception is the example of unchecked exception. Okay, so that's all for this video. Thank you for watching.